To talk about wireless, we need to start with wavelengths. This is not a physics lesson. I am not equipped to deliver that message, but I do want to talk about how wavelength affects how our radios work. All wireless technology is reliant on radios. So, if we think about where the visible light spectrum is, which you can see on the slide here, think of visible light of something that can't really get through obstacles super well. If I kind of shut all my windows and have a door blocking, the light's not going to get through that door. It's not a very penetrative wavelength of obstacles. So the closer we get to the visible light spectrum, the worse the penetration through obstacles is going to be. So we want a longer wavelength, a lower frequency, because those wavelengths are better at bending around objects and going through objects like walls in a house. That will give us the longest range because it's got the best kind of penetration through obstacles. You can also think about how the bass comes through your ceiling from your neighbors a lot easier than the treble because the bass has a longer wavelength and a lower frequency. Now, conversely, the higher frequency, the more bandwidth you get. If you think about every time that wave crosses the x-axis as being a zero, the more times it crosses that axis, the quicker you're getting your information, the more bandwidth you have. So now we're trying to balance these two things, the range we can get from our radio, but we want more bandwidth. So this is something that a lot of wireless technologies are trying to balance.